what makes an artist is somebody who is able to look at the graph of possibility that's out there and navigate it, right? Like there's no formula that's going to tell you, oh, this is the way that I should put on Hamlet, right? There's going to be convention out there of how it is, but everybody who's like directing and performing inside a production of Hamlet is bringing their own tastes to the equation. And the artist is somebody who can say, I'm going to create a compelling narrative, a compelling production, which is consistent in and of itself. And I think that is not going away with generative AI.
I'm with Zach Johnson, co-founder of LMNT, a startup working in the field of voice synthesis. Zach, let's dive right into the problems with voice and how you're hoping to transform content creation and translation. Welcome.
Yeah, thanks for having me. This is great. I love talking about this stuff. That's why we're working in the space. So I guess quick kind of overview. We're working in the voice synthesis space. We are working on creating lifelike or human voice, particularly in the game spaces where we're working right now. So our first entry point. And we're excited about this because we think there's a huge amount of opportunity for creating really compelling experiences, right? Like when you look at like traditional voice synthesis, like it's kind of robotic, it's kind of flat, like it just doesn't have all the richness that makes like human speech compelling. And we think we're positioned to solve that. We'll play a demo a little later on. You'll hear some of like actually what's coming out of our systems. And I think what's really interesting about the potential here is turning voice into something that's more IP. So say you're like a voice actor. Today you're licensing your performances, right? You put on performance, you go and for a game, you're the voice actor for this particular character. Great. You've created that performance, but that's all that the company is buying from you. And you have to go put on that performance every single time. But what if that was more IP that you had, that you could actually license your voice? So you could go create many different characters and scale yourself, right? Like there's a whole lot of opportunity here to be able to go into different languages, things that are just like superhuman possibilities that are like, haven't been possible before. Where you can now be the voice actor for this game in all these different locations, right? Like now you can get paid for that when you weren't going to be able to before. So that's kind of interesting. I think it's really 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 cool to think about what's possible for game experiences in particular, dynamic content generation, things like that, where you don't have to have recorded every single line that's being said, but adding all that richness of like a real human.
Well, let's take a moment to actually play this. When we do videos, normally like we just show imagery and it can go at the same time, but this is something you have to really hear to appreciate it. So I've got a recording here that you put together with David Attenborough, or based on David Attenborough's voice. Do you mind if I play that? And
let's do it.
And we can talk about it a little bit. Okay, cool.
Across the vast shallow waters that comprise the San Francisco Bay and the broader Silicon Valley itself, we find the home of a peculiar species. Hidden among the reeds in the marshlands, we find the CEOs of big tech.
That to me sounds amazing. I'm not like the world expert in listening to voices, but when I hear that, if you had just told me that was David Attenborough speaking, I would have believed you. There wouldn't have even been a question in my mind. Can we talk about voice a little bit more first? Like,
yeah.
Why is it that as I listen to that, I'm convinced there's something going on there that's just beyond sort of matching certain aspects of voice that I'm accustomed to? It actually sounds like him speaking.
Totally. So when you think about speech, there's a bunch of different dimensions that make it real and natural. Obviously, the biggest one that you think of is just the texture, the tone, right? Like pitch, like where you are, like all that is kind of first order, like the business, you have to get that right. But the technical term that the industry uses is called prosody, which represents all of the characteristics, including those that you're used to thinking about. But this is the pacing. This is the where's the pauses, where's the emphasis, which words do I go in, and like where in those words am I putting that emphasis? And that is not something that is like easily achievable in like short like zero shot kind of stuff. Like great, you can do zero shot. That has some interesting characteristics, but really if you want to get that real full richness of a human voice, you have to look bigger, and you have to really represent that well in your model, right? To make sure that you have that being produced on the other side as well. Um, so yeah, I mean, like you look at many different like popular voices that are out there, and they all have very very different characteristics, right? They might be more rapid fire, things like that. Like that's and all of that needs to be captured for you to say, yeah, this is David Attenborough, or oh, this is so and so, or and that is sort of the magic that we've been working.
So, Zach, I'm reminded of what really great impressionists do when they take on a voice. Like probably things like you were talking about, like the pure texture, the pitch, they probably get close, but actually what we hear from an impressionist is more about timing, pacing, like how do they pause along the way? Like to me, that's the key to like those kind of performances. And when you use this word prosody, it sounds like that is what you're trying to capture through this form of synthesis.
Yes, like that prosody, the everything that makes that voice you is something that you have to hit, otherwise it just doesn't come across quite right. Like it becomes more uncanny valley than it does become an actual like believable performance, right? So yeah, I mean, there's a lot in speech, and what's really interesting about the like problem itself is it's not really solvable until you have generative AI, right? Like when you think about a lot of the AI systems that have been built and deployed in production for the better part of multiple decades, a lot of them are classifiers, right? It's that you're taking place where there's more information and distilling it down into a small number of labels saying it is this, it is that, it's this other thing, and those are great. That was very very helpful, right? Being able to help moderate content and like be able to search your images on like Google Photos or things like that. Like there's some really amazing things you can do there. But when you think about generative AI is flipping that around and saying we're going from something that is low information to something that is higher information. Like text is never going to be enough to put on a convincing performance. Like you can't look at a text like David Attenborough will say something very differently than say Matthew McConaughey or your other favorite actor in there, and each of them will say it many 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 different ways too, right? Like you could have Matthew McConaughey saying all right all right all right, or you can be like all right all right all right, like like there's a whole all that dimensionality means that you have to have generative AI in the picture flipping it around and saying, okay, well, we're going to go from this information to something that's higher information. And what's interesting about that too is it does mean that a human still needs to be in the loop to help guide that in some form, right? Like making the choice. Like generative AI is not going to. I mean, it may get the performance is generally correct. It can look at context and things around there, but at the end of the day, you still have somebody going, yeah, this is the performance characteristics that I would like out the other side, right? Someone's in the loop, and yeah, I mean it's that's the part that makes it fun, right? It distills the creativity down where you don't have to worry as much about the performance, but you're actually worrying about like how you want it to come out the other side.
That's a really interesting idea because I remember years ago I took a course on Shakespeare, actually. And one of the most memorable parts of the course that the professor included was she brought in an actor to actually act out a scene from Hamlet. And he acted it out one way. And then he said, okay, now I'm going to do it again. It's going to be the exact same words, but it's going to be a completely different impression. And it was actually amazing how he delivered this experience. So is that part of what you're talking about too? Like I'll be able to kind of direct and provide guidance in terms of whether I
Yeah.
the question mark on the end of all right, all right, all right, or
Yeah. Yeah, like it's I think that's the world where we're going to live in, right? Where you're going to be providing context around how you want performance delivered, and some of the magic is because that's the creativity, the art in the space is like being able to put on something that is unexpected sometimes too, right? Like it's not like you have to be able to have the unexpected. TV, movies, games generally, a lot of things rely on that element of surprise, right? Like jokes often rely on that. They subvert your expectations, and sometimes you maybe you have like a complete twist on, say, Hamlet, right, where it becomes something very different, and that is because you have that context of what Hamlet is originally, and you when you see it, you're like, oh, this is something new, interesting, exciting, because it's like what I expected, but it's different, right? And that is like, I don't know, that's art generally. I think if you even get into the like philosophic thing about like what makes an artist, is somebody who is able to look at the graph of possibility that's out there and navigate it, right? Like there's no formula that's going to tell you, oh, I have this is the way that I should put on Hamlet, right? There's going to be convention out there of how it is, but everybody who's like directing and performing inside a production of Hamlet is bringing their own tastes to the equation. And the artist is somebody who can say, I'm going to create a compelling narrative, a compelling production, which is consistent in and of itself. And I think that's like, that is not going away with generative AI, right? Like the navigating the web of possibility is still there. Yes, you maybe have generative AI helping you explore those possibilities and see, well, what would Hamlet look like in a completely different turn, right? Like if we put entirely different characters in there, and that might be really compelling, right? But somebody still is there saying, I have an idea, I want to experiment and try with this, right?
seems like that's what's been missing from some of the other voice synthesis technology that we might be able to identify, which is like you're almost talking about like this aspect of intentionality behind the speech and being
Mm-hmm.
able to provide more of that intentionality so that there's direction, there's a trajectory to it, there's an emotional impact that you're actually trying to deliver as opposed to just here's some words, say it in a way that sounds like somebody.
Yeah, and I will say, we're working on that problem. We're not quite there yet, but that's the world we're working towards, right? Is like, okay, we can put on David Attenborough as an example, right? Like we can put on a performance which feels like that, um, but I think, yeah, we need to get into that world where you are able to provide directions more, right? Like we have some control, but it's not enough, and that's where we're putting a lot of our investment.
This sounds like a super hard technology problem, a science problem, a math problem. Like, let's talk about that a little bit. Like, how do you do this?
Well, some of it's secret sauce I can't get into, but I will say, but I will say there's a lot of like user study that goes in first, like figuring out like what resonates with people, right? Like we need giving as much information, running experiments, just starting with ourselves, but then also with people we know and trust, and bringing them on board to give us feedback. But then there's a bunch of different like all things, there's a bunch of different ways that we could solve these problems. So we end up running a bunch of experiments and trying out different architectures and things like that to see, if we flip this whole thing around from what we were originally doing, okay, well, does that help us? Maybe it helps. Like what we do a lot of is reading research papers, understanding like what is the technique that they're bringing to the picture, and actually implementing them. So if you go and look at our like GitHub, we have some open source stuff that's out there. That's not necessarily stuff that we're using in production ourselves, but we have implemented several research papers. Actually, some of them are even being like cited by other researchers. Like there's one of them, our implementation of diffwave actually sort of became the de facto implementation that other researchers are using. and cited by like people at Apple and things like that in their research papers. And it's like it's really cool to see that. Like, no, we did it just for ourselves, and if other people are getting benefit out of it, that's great too. But we'll experiment with these things and see like what is the technique, and then from there, decide, okay, is there something valuable about what we learned there that maybe is makes sense to bring forward or incorporate. But yeah, it's there's a lot of trying to stay on top of what's the state of the art and understand what's out there, because there are sometimes novel, interesting things that gets published that like is genuinely helpful. And yeah, there's a lot of math that goes into it. Sometimes like starting out when I was getting into the space, you read through the research papers and you start glossing over when you start hitting the math section, right? And you're like, okay, yeah, there's also linear algebra. Let me, bring that back up into my load it back into my cache.
Mm-hmm.
uh, but then, yeah, you start going through implementing it, and it kind of starts to make more sense and all that, and maybe glaze over less over the math. Yeah, and then there's a lot of it is experimentation, and then trying things out, and then I think also trying to understand more about what our models are doing too. I think that's pretty valuable, because if you understand what they're doing, that helps you. I think there's a lot in the ML space that is it feels like throwing jello at the wall and kind of seeing what sticks and what doesn't, right? It's just kind of like there's a lot of just, oh, let's try this, and I get it. Like there's a lot of the, especially the research papers and stuff that go out, like you're working on your dissertation, or you're working on your master's, and you have one angle and you're just like pushing on that, and that's important, right? But I think there's a lot of, how would I put it, lack of understanding of these systems, I guess, which means that you're kind of fumbling about in the dark a lot too. Like imagine like building operating systems where you don't understand what's going on, and you're just like poking around and seeing like, oh, let me go change this code over here and see what happens, right? Without understanding, without being able to understand what's going on. Like that's not a world you really want to live in. Like it's, you can, but it's highly inefficient, right? And yes, machine learning makes it easier because you can have the computer try out a bunch of different combinations, but it's really helpful if you can understand a bit about what the model is actually learning, and then try to go optimize from there, right?
Yeah.
Like I think there's the apocryphal story about like when was it, I think it was something with like actually with generating Shakespeare content, right? One of these initial models that like somebody had, and they, it was very rudimentary. I forget what year this was, very rudimentary, but as the story goes, uh it would generate stuff that looks like Shakespeare, and they started flipping around these different neurons inside the code that they had written, right? And they found one that if you changed it, it outputted negative Shakespeare, and if you changed the other direction, it was very positive and happy Shakespeare. And they were
Huh.
like, huh, there's something there's something here. Maybe computers can actually learn some of these things. They can learn structure. They're not just like throwing stuff at the wall completely blindly, randomly, right? Like it's there's something here. And then that was sort of the moment for their realization, saying, oh, yeah, let's do. Maybe you could do much more. So I think that's something important. We need to bring more rigor to the ML space generally.
I want to return in a little bit to some of what you were talking about, like the eyes glazing over as you look at the calculus and linear algebra and some of these papers out there, because I think that is the experience of a lot of people who started from a comp sci background and are trying to figure out how they're going to advance the next stage of their career. Before we get to that, though, let's talk about DiffWave a little bit more. Probably most people listening to this are not audio experts, and especially not machine learning audio experts. Like what was the innovation there, and what are people making use of?
With DiffWave, I guess I'll just keep it super high level. Really, like when you look at some of the innovations, like there's the diffusion concept, which you see like everything that you see generative AI at the moment is pretty much based off of that.
Mm-hmm.
So DiffWave was, what if we applied diffusion to speech synthesis, and where would that take us, right? And this was starting from noise, trying to generate something which sounds like, whichever speaker. Unfortunately, I've sort of moved DiffWave out of my cache, so I can't really refer to it as much, but because we've moved on from it. But I will say this was a really interesting paper. There was a research group at, I'm blanking on which university right now, but they had this, was it university? Anyway, they published this paper, and we implemented it within 24 hours, and then that's why people started picking up on it, because like the other people hadn't even released their implementation, and they actually, I don't think they ever even actually did, because they didn't necessarily, they had to go through all these approvals to try to get it released from the university and everything, and it was just quicker for people to use our implementation. Um, and I think there's a lot of, like, diffusion as a concept is it's relatively simple, but it's super powerful. Going from noise, it's kind of, you're just like, what is this dark magic where you like, oh, let me just create some noise and like go backwards from that, or let me mix noise together and but what's interesting about diffusion is it learns how some of these things relate, right? And then when you're coming back out, you're able to guide the synthesis, or guide the result on the other side, move it in different directions, or add in something else, or like, yeah, it's really really cool. And then particularly when you look at the papers, like you had the Berkeley team that came up with diffusion initially when they're applying it for face generation, and then there was a Stanford team that looked at that and realized that they were solving an entirely different problem that was applicable in the same, like basically the Stanford team went and said, okay, Berkeley's got a discrete process where you have like a number of steps that you can come backwards from. The Stanford team realized they could formulate it as a continuous problem, which meant that you could choose your steps arbitrarily, and that was sort of the beginning of the magic of, okay, well, we can train arbitrarily. Great, we can make arbitrary steps, and yeah, that's kind of diffusion is like really really cool, but it's something that you need more than that. So we experimented with diffusion, it was great, but there's much more to the picture.
Okay, so you're working on your secret sauce, which will
Yes.
take it to the next level.
Yes.
But sort of the first steps into this were from, it sounds like, things similar to imagery, where you have this big neural network that kind of understands what a cat looks like, and like these data points that establish the rules of the way
Yes.
that would be drawn, and starting from pure Gaussian noise distribution, you can kind of surface out of that this image of a
Yep.
cat, like progressively going through a sharpening process,
Yep.
essentially. So
Yep.
that was, I can see why that would apply to sound.
Yep.
But we're all discovering new ways to do this. Let's talk a little bit about your own journey as an entrepreneur. So before
Yeah.
this, you were at Google for a whole bunch of years working on Bluetooth and
Yeah.
consumer products. That doesn't sound like machine learning, obviously, to me. Tell me about
No,
that.
yeah. Yeah, so I mean, like, I've never really shied away from hard problems. That's kind of been a thing in my career. And so when I started Google, I joined into the Glass team, which was like a dream come true. Still, like, by far one of my favorite teams I've ever been a part of, and for a bunch of reasons. I mean, yeah, working on cutting edge stuff, but also you had this team which was, I don't know, like, how to exactly put it, like, it was lightning in a bottle, right? Like, you had a whole bunch of engineers all running in the same direction. Everybody was amazing. Like, I walked in and I was like, I'm the dumbest person in the room, and this is great. And we worked really hard on it too. Like, all that kind of mixed together created this amazing moment in time, and that's actually where I met my co-founder now, Charvel. We were working together, and it was pretty much instant. This like uh, magic experience of, he's taking this part, I'm taking that part, and we're just like knocking things out one after another. But like, okay, joining into the glass project, um, I wanted something that was high impact in the consumer side. Like, we were also doing enterprise stuff. That was kind of the more more later years of Glass after we had all left was more on the enterprise side. But I wanted consumer, like I was like, I want to have an impact on the future of computing, right? Like chances are that the product that I'm working on at that Glass at the time, is it going to be successful? There's a pretty high chance it's not going to be, but it's going to have some kind of impact. And in 20, 30 years, we're going to look back and say, yeah, like we changed the world or helped change the world. Um, so yeah, getting into Glass project, where was the most important and impactful and difficult problem to jump in on? And this was Bluetooth, because you have to talk to the internet. If you cannot talk to the internet, you're just a fancy camera on somebody's face. The world. I like to say the world's worst spy camera, right? Because you're like wearing it on your face, right? The whole backlash against it was hilarious because people are like, "Oh, people are spying." And I'm like, there's like other ways that people spy which don't involve a camera on your face, and
Be a lot less obvious.
yeah. uh, but that, and also the battery life would not have lasted that long either. So there's a whole bunch of things, but like we had to talk to the internet, and Bluetooth was just garbage. I mean, it still is kind of terrible, but at that time, why was it in such bad shape? It's because it was a nice to have. You had your business people that would wear it or whatever, have their Bluetooth earpieces, the classic, they're talking to themselves, right? Ooh. But now at that time you started having more companies built around us. Like, we need to be able to talk to these phones. Your phones become that central part. It was terrible. Like, I will tell you, our success rate was something like 70% for like asking the glasses a question, which means 3 times out of 10, it's like failing to give you an answer, because and it would disappear somewhere in between, right? Like between like the app on the glasses and the phone, it would just like not happen. So we jumped in on that. People were running away screaming from that area because it was really difficult. But we started having impact, right? Like, we shipped a bunch of changes that went into main Android. So that's I guess, to sum it all up, I could go way down the rabbit hole on Bluetooth, but it's a really hard space, and it requires a lot of patience and being careful, and like you have to be careful not to break the world. And the my journey at Google kind of centered around Bluetooth and connectivity because it was an area I could have impact in. Uh, yeah, pretty quickly, 2 years into joining, I then started managing my team. I guess I lucked out a little bit as well, because I think because people were running away from the area, there was less competition, obviously. but at the same time, I think it was an opportunity I couldn't pass up to learn more about, okay, it's not just the building of software, but the building of teams, and how are you going to get the right mix of people on your team, which is really helpful now, being in a startup space where you are assembling your team,
Mm-hmm.
and learning about different failure modes, right? Like you can have a team which is super high performing, and then you introduce the wrong person into the equation, and now you've kind of broken it, right? And what do you do when that happens? How are you going to have those really hard conversations? I do not like having those conversations, right? I like happiness. I like people like working together, and harmony, and having those like difficult conversations is hard, but sometimes you have to, right? Or you do have to, as a leader of a company. And that was a good place to start spreading my wings, and learning about that. And eventually, by the time I left, I was managing managers, and that's kind of fun because you're able to uh, like you're able to provide guidance and help to the people on your team, but maybe you're not also always having to have all the hard conversations. It's leveraged impact, right? Um,
Mm-hmm.
so that's why I stayed in the Bluetooth space, was I was continuing to learn, continuing to grow. But then I think the thing for me was like deciding to leave Google was seeing that there's a lot of really cool stuff happening in the AI space. And number one, I just wanted to learn and become familiar with the space, because I think to be relevant in 20 years, you're gonna need to know how all this stuff works, right? Like, I think there's a couple changes in the industry that are happening. One is, of course, AI. The second is the like memory safe languages like Rust and other things like that. Like, we should stop producing code in C and C++. Stop shooting ourselves in the foot. We need to be moving to these safe systems, because the cost, like the cost that I saw on the other side being inside Google, is astronomical for security vulnerabilities. It's not just the cost of, like, yes, we had to go roll out and QA and all this other stuff, but it's also the cost to your brand, right? Honestly, right? Like, you've
Mhm.
so a whole bunch of costs, and so we need to stop doing that stuff. So I think if you're gonna be writing system software in 20 years, you need to learn Rust. You need to learn like all these the, those languages which are going to help you keep yourself sane. And then on the other side, there's the AI stuff. You're going to need to know how all this stuff works in order to, like this is like foundational stuff in 20 years you're going to need to know. So I was like, you know what, I need to start learning this stuff more in depth, more than just like the high level stuff that you read, like articles and kind of do some of the basic, like, AI 101 kind of stuff. And that's where, it was like the perfect timing with my co-founder, where he was looking for somebody to also come join in, and we'd worked together in the past. It's had those magical moments, and so I was like, you know what, yeah, this makes perfect sense. Let's do this together.
Yeah. So I heard a whole bunch of things there. So first of all, the worst decisions I've ever made in my career were in the situations where I had the extremely creative, super smart person on the team who was really not at all getting along with the team, and I I kept them in that team longer than I should have. And I feel like in the game industry, this probably happens more often than a lot of other industries, just because you are
Mhm.
dealing with people who are so creative and they've got these ideas, and they
Yeah,
really cherish the ideas and they want to run with it. They want it to be successful. And yet they don't really know how to sell their ideas effectively. And that can be a real collision. So it sounds like you learned a lot about that. You learned about the importance, broadly speaking, of team composition, and that's where you met your founder. I think it's incredible for startups when you can, have some past background working with someone when you're starting something new, because it cuts through a
totally.
lot of the crap. You talked about memory safe languages like Rust, which I would say more broadly, it's like systems are way bigger than they used to be.
Yes.
User,
Yes.
you can have hundreds of millions of users for a system, right? So
Yep.
the scalability of that system, which is on all kinds of different axes, memory safety, just the ability to be performant, deal with users, the amount of data storage, like really understanding those attributes of system design. Because also I find that this happens with games, but it can happen with anything. Like things can also scale way faster than you were expecting. Like you can ship a game now, and there could be 10 million people playing it the second day. So
Yep.
you might probably want to think about that. That's kind of some of the problems that I've tried to tackle.
Totally. And in that world, you have to be careful about optimizing too early, obviously, because you could spend time on a problem that is unimportant ultimately. But if you have the experience designing the systems and dealing with some of the scale, you can bring that knowledge to bear so that you can make better choices up front, which will make it less painful later on, just completely integrated in your normal development experience, right? Like this is the sort of, I guess, to flip it around, like the neural network you're building yourself of, like, where are these problems going to be, and let me like steer away from them if possible, right? And yeah, you have to. I think you really only learn that by, like, being bitten by it repeatedly, right? Like you're like, oh man, if only we made these choices. Um, and that is, I think, like maximizing your learning is something, especially earlier on in your career, that is a very good thing to do. Maximizing your learning and maximizing the people that you get to know, because that's going to be really helpful later on.
Yeah, I so admire your devotion to learning and curiosity. I feel like curiosity is like my number one kind of core value that motivates me. I wake up in the morning and I'm always like just trying to learn new stuff, and then apply it during the day in those early hours before I start having like work interrupt.
All the other things come in and you're like, oh right, I got to deal with this. Like you have to reserve that time. That was another big thing that I learned being at Google, was like there's so many things that you could be spending your time on, and you have to carve out and say, I'm going to ignore all these other distractions. And if that is like, I need to book for management stuff, I need to like book out like 2-3 hours on Monday just to like get my head in the right space and kind of do some stuff for planning. Okay, I need to do that. If I'm in this case, so at Google, I kind of stayed in the like kind of manager and kind of engineer track combined together. Technical lead and manager is what they call it. And so, you're kind of doing two jobs at once. And if I wanted to stay ahead on the engineering stuff, I needed to reserve time and say, I'm turning off emails, I'm turning off chats, I am, or if I'm at work, I'm putting on my headphones saying like, don't bother me right now, I'm busy, right? Of course I'm open if somebody really has something important. Yeah, I can help with that. But like you have to reserve that time because it is so easy for it to get sucked up by other things. And then yeah, like you can be curious, but if you don't act on it, you haven't really you haven't taken advantage of your curiosity.
So a ton of people are going to want to go on a learning journey similar to yours. Maybe they're a software engineer and they want to start absorbing more machine learning into their skill set. So like level one is like, okay, you're in VS Code and you're using Copilot, or you use GPT-4 now to help you solve a problem. Awesome. Like definitely learn to apply those tools, or I think
Yes.
you'll have a problem. But like take us on how you can maybe learn the next level, like actually integrating machine learning, AI knowledge into the toolbox so that you could actually build software systems around these things. What did you have to learn?
Yeah.
Or I guess more importantly, what would you tell someone today who's about to do that, what they should focus on?
Yeah, I think there's a couple things. One is find a problem that really excites you. This is just generally true,
Mm-hmm.
right? Like this when I started out doing programming, when I was like high school, right? I was like, okay, there's this problem I really want to solve. I want to be able to launch apps faster, for example, right? And I want to have a little box on the screen that I can type in. And that's the thing that kept me excited and engaged. And you're going to have your ups and downs, right? Like this is true of life generally. You have your good days, you have your bad days, you have your good mornings, and you have your bad nights, right? Or your good, like life is this roller coaster up and down, and you need something that is your north star, that is keeping you attached to the problem enough. It's kind of, I look at it as leveraging the sunk cost fallacy to your own benefit, where you're like, oh, just another hour, I can solve this. And then, like if you would have told you at the beginning, like this is going to take you, you know, a month to learn all these concepts, you might say, is it worth it? I could go, I don't know, watch TV, or I could do like all these other things where like I could do something that gets me that excitement at a lower level, but just is easier and more accessible, right? So you need that problem. So find that problem, whether that is contributing to some other open source project or coming up with something, and even if it's already been done, like kind of clean room doing it yourself and saying like, how would I work from 0 to 100 for this? Find that problem first. Then everything else is going to organize around how you're going to solve that problem, right? So if you need to learn how do classifiers work for your problem, you're going to learn how they work because you're like, I have this application. So start there, um, and kind of use that as your explore phase to just kind of learn how do these systems fit together, and repeat this a couple times. You're going to want to do that just so that you become familiar with the space. But then I think there's also something important about taking a second pass through. So and this is like you go write prototype code to explore, and then you go and write production code. That's a second phase, and I think the same thing needs to happen for learning.
Mm.
This is sometimes why people will even go pursue masters, right? Like even if they've done a bachelor's, or they've self-taught, like you want to kind of go through and see this a second time, because you have the benefit of all of this other pieces of the puzzle that you've connected together, other parts of the knowledge graph that you exist now, really help you cement your knowledge. But then the other thing is dig into why. Like when I look at the beginning of my journey of, well, even just becoming a programmer, right? There was a lot of these magical incantations, like, oh, Java, or like public static void main, blah blah blah, and it's just like these magic words that you say to get the computer to do the right thing, right? You don't necessarily understand how they fit together, but once you understand how they fit together, now you can start navigating a lot better. So when you understand, for example, how the Java runtime environment works, I remember that one of the professors I had at university was always just like, always drawing like, here's how the Java runtime environment works. By the time you got to the end of that class, at the end of the 10 weeks, you're like, yep, it's, okay, this is a very, very high level diagram, but now I understand, you've got your like class objects, you've got your virtual environment that is interpreting the bytecode, like all these things, like you understand how they work and the magic goes away. And that helps you much later on when you're like, oh, how am I going to solve this problem? Like I had several problems where uh, at Google where there was code was behaving weirdly. And well, why was it behaving weirdly? Because there was all this, additional, like they call it ProGuard or things like that. You're putting around it to try to clean up and remove like things that weren't being used, make it so that you can ship this to the end user and use them as little space as possible. Most of the time it got it right, but sometimes it didn't. And now you have to like dig in and figure out how it works. If I did not have the knowledge of how the Java environment works, I would have been so lost, right? And that's that same parallel I think applies in the machine learning space. There is a lot of like I will say black boxes, like dark magic, and like areas where people don't understand how it works. But there are people who are exploring some of those, and I think we're going to see better tools in the coming years, hopefully, that will give us better insight into how these models are working. Like I would love for that problem to be solved, because I think that's a problem that is everybody in the machine learning space is facing, of like what the hell is going on in this soup of linear algebra, right? Because there's something going on. Obviously we're getting some interesting results, but like how does it work helps you navigate, and that like take away the mystery as much as possible when you're learning, and you're going to be that much more effective later on. Now you're not going to be able to get there all in one jump, but take those successive passes, be intentional about it, be intentional about the depth first versus the breadth first, and you're going to be in a much better spot than somebody who's just like throwing stuff at the wall.
Yeah. So for me, I find just identify the thing that's just outside of what you actually can do and then just start working on it, which I parallels the advice I always give to people that want to join the game industry. So the game industry is like one of these weird like break-in industries. Like people are mystified by like how you get into it because it seems difficult. Usually I say, well, have you made a game yet? Like,
Yeah.
how about you start working on a game? And whatever your skill set is, if you're a designer, if you're an artist, if you're a programmer, frankly, you're going to learn a little bit about all those things once you start actually developing a game. But a game company wants to see that you have worked on games, and that includes entry
Yeah.
level positions. An entry level position means you have a portfolio. No one's expecting you built a AAA game by yourself. They're expecting that you solved some problems, and they want to see how creative you are and how you can kind of assemble games, which are super complex systems. Speaking of maybe
Yeah.
the closest thing to like this black box of linear algebra that you're referring to. Just start working on it. And there's awesome resources out there. I'll link in the show notes my own article that might send people on a path to learning some of these things. But you could also just go on to Kaggle and like join a team and see if you can solve
Yeah.
a machine learning problem. Like tremendous resources out there.
Totally. And that is the important part there, of like not expecting perfection to start.
Mm.
Like getting the car rolling, so to speak, right? Like it's a lot easier to steer once you have the car moving. And yeah, is that like you may get lucky in that first team or that first project. You may have, I don't know, a Flappy Bird on your hands, right? Maybe, right? But it's super, super unlikely. But if you optimize for learning up front, optimize for learning and meeting people, right? Like this is another thing that like was sort of an unexpected benefit of that first team Glass that I was on.
Mm.
So Glass, there was a whole bunch of turmoil that happened like a year in. I could go for hours about the whole story there, but the gist of it was the team got like pretty much wiped out. In turn, like everybody left and went to other teams. Like, and I was pretty bitter about that to start with, because I was like, God damn it, I spent so much time on this, and we all spent so much time like trying to get this right, and then ultimately it was things outside of our own control, which brought that down, and and it wasn't like it was we couldn't have optimized to solve that problem in any way. It was like leadership stuff and things like that had happened, and we went from like 100 software engineers to 4, and which is like terrible, really, really terrible. And I was bitter because I was like, you know what, we spent so much time on this. It was like, like it went from I will spend 18 hours a day doing this because I am so excited to like, when can I go home kind of thing. And I was like, you know what, this. And then about, I would say, like a month and a half after that whole event happened, and kind of got on the other side of it, and like past all the stages of grief of bargaining and everything, right? uh, I realized I got paid to learn a lot of lessons that I didn't have to make those mistakes myself, observing leadership, right? But the other thing was, now I had a bunch of friends all over the company and also scattered throughout. And so I guess the moral of the story there is, optimize for finding smart people to work with, optimize for being the dumbest person in the room. And if you're working on a project, you're working in a startup, and it folds a couple months later, that sucks. But at the same time, now you have a whole bunch of friends. Hopefully, if you've done things right, you've got a bunch of friends, and you also have been able to learn how to work with them, or these people that you've met on, working on like an open source project together or whatever. Now you might, who knows, it might boomerang back around in a couple of years. You may say, oh, we need somebody exactly like this person. Well, let me go call them up. And yeah, you've already got a working relationship with them. Like, there's a lot of things that you can optimize for. Don't necessarily optimize for perfect, optimize for good, and iterate, right?
Yeah, I mean, product failure, startup failure, things like that. Those are not the worst things in the world. You can use that time really valuably to, build skills, build your social network, build all the things that you'll carry forth into the future.
Totally.
I wanted to return back to some of what you were saying at the beginning of this conversation around business models and like the transformative impact of this technology.
Yeah.
It's really interesting because there's a lot of people who are super afraid of AI and machine learning for a whole wide range of reasons, but in particular because it's going to affect jobs, right? And labor and
Mm-hmm.
things like that. And there's also people angry at like intellectual property and what they see as, unfair use or theft or whatnot. You're talking about something else. So which to me, if I think through like the history of audio, right? Like
Yeah.
it once was just something where people performed and you couldn't even record. And then suddenly you could record and you could replicate yourself many times over. It essentially made performance something scalable. You're like talking about the next exponential scale that you could bring a performer, right?
Yes. Yes. Like, I think a lot of the fears, a lot of things are rooted in reality, and there's bits and pieces of truth in there, right? Of like, yes, jobs will change a bit, right? Like that. I mean, that
A
is,
lot.
when you look at every, or a lot, yeah. But like, when you look at every sort of technological shift, you can go back to like the printing press. Like, the printing press changed a lot, right? You could mass produce a bunch of these things that were not possible before. You look at TV, you look at radio. Each of these shifted how we worked and what types of jobs were available, and where skills were valued. Um, but it was a shift. We adapted, and we retooled. And I think when we look at, like, I think what you hit on in what you were just saying is, and it's exactly true. Once you can start to IPify like a voice, you like there's always, I think there's, I guess, let me take a step back. I think there's always going to be room for like artisanal performances, right? If you want to put it that way.
Mm-hmm.
Like, you look at, like, there's some actors, for example, are like, super super in-depth method actors, where they're like, I'm putting on this character, I'm gonna go learn to ride horses because I think this is important for me as an actor. Now, did they have to do that in order to perform in the movie? No, but they're like, this is part of my method. And I think, just like you like, music being recordable and shareable and streamable didn't get rid of live performances in any way, right? In fact, it had a lot of help because there was discoverability, right? Like, you could go, you're like, not like, you go have your Spotify subscription, and there are so many artists that I would have never been able to listen to before that now are getting revenue from me listening to them, right? And I will consider and have actually gone to many shows of these folks because I'm like, I want to go see this in person. And there's a different energy often too.
Mm-hmm.
Like I remember this one, like there was this one conference, music, I guess it was like a whole day over in Mountain View at like the Shoreline Amphitheater. It was a bunch of like, indie alternative. And I was like, holy crap, this is an amazing experience. And like hearing the difference between live and like recording, like the recording is great for its own reasons,
Mm-hmm.
but yeah, I think there's a lot around discoverability that there's a lot of opportunity here for voice actors to take advantage of this shift, just like the people who took advantage of the streaming and music recordability shift also were able to take advantage and get some really good benefits out of, right? Of like, yeah. So I think there's a lot of opportunity here. I fully understand the concerns, or at least I feel like I fully understand a lot of the concerns. But I think it's the shifts are always hard. But I think if you look on the other side, I think there's a lot of opportunity.
Yeah,
Put it that way.
I mean, having worked in the game industry for a while, I know a lot of voice actors, and frankly, a lot of them are somewhere in the continuum of angry and afraid of the changes that they really just see
Yeah,
happening. But a voice actor does a lot of things in the process of working on
yeah,
something. And one part of it is the performance, but a big part that frankly they're not really paid for today. I think they want to believe they're paid for it, but from the buyer standpoint, they're not paying so much for the fact that this voice actor is actually designing the way
yeah,
that character is going to manifest within the game.
yeah.
And this is a way to capture the design process and turn it into a form of intellectual property that voice
Yes,
actor now creates. So maybe we'll have a job in the future, which is like a voice designer, is the next
yeah.
evolution. That probably
Like you look at Hank Azaria, right? Like The Simpsons. He's got like so many characters that he's created, right? And that's his thing, right? He goes and they tell me about the character, and I'm gonna go and design the voice to go with that. And I mean that is very valuable work to be able to do,
Mhm.
right? And I think there's I think there's a lot of potential for voice actors to also scale themselves too. Like maybe if you're like you look at the cameo kind of model, right? Where there's like you have the cameos where you can go and get celebrities to like say something for you, right? Uh, Now that does require the celebrity to take time out of their day and say, "Let me,
Yes.
okay, I'm in the car, I'm moving," and do that. Now imagine a world where you have the celebrity has their voice that they can make money off of, and maybe they want to go hire somebody who will do the work of making sure that the voice that's like doing the cameos for them, right? Where it's like, okay, make sure it's not going to say something that is not is out of character for me or something like that. That might be an option, right? Like if you have so many people who want cameos from you, for example, like you could do that now, whereas before it would not be possible, right? So yeah, there's a lot of stuff swirling around, a lot of possibility, but I think where you're going to see a lot of interesting stuff in the game space. This is what we're really excited about, is this dynamically generated stuff, which is just not possible before, right? One other demo that we have up on the YouTube is Flight Simulator, and you can see my Flight Simulator over here. I've had a little bit of too much fun with it, you can see, but I've added like wind and things like that. I like hacked the or reverse engineered the protocol to talk to these fans so that I could tie it to the engine RPMs in game to like make it actually be realistic when I'm changing the throttle. But so with Microsoft Flight Simulator, uh, when you're a pilot, there's like three things that they drill into you, which is aviate, navigate, and then communicate, and in that order, right? If you have to drop them, drop communicate. If you have to drop another one, drop navigate. You just need to keep the plane in the air, right? Now, if you look at the flight simulator experience, they've nailed the aviate part, right? Like you flying around, you've got this great experience. You got the navigate part, you've got your maps, but the communicate part, not that great. Like you've got these sort of canned voices. It's very very rigid, and you're also not speaking to it. It's like you're like it doesn't match up with reality of flying a plane, right? Of you have a little like window and you're saying like, I want to be cleared to land, I want all these things, right? And one demo that I did, like hacked up over the weekend, using our voice stuff, and we put it up on YouTube. It's like as recorded inside my VR headset. Is what if you could completely change that communicate experience? So you'll see in the demo, you've got real traffic piped in. I'm recognizing what is pilot and what is controller, and this is the sort of magic part. I have a cloned voice of a real controller that I'm able to synthesize in. So now I can go take the real pilot, real controllers, real air traffic, and change it to be the synthesized voice. And then I've got me speaking to the game, and it's replying to me in that same voice. So now I've got this like mixed reality, like world where Flight Simulator doesn't feel as much of like a solitary experience. I hear stuff that's going on. It feels real.
United 821, runway 19 right, line up and wait.
19 right, line up and wait, United 821.
Tower, Cessna November 501 Sierra Charlie, with you for 28 right.
We're going to 501 Sierra Charlie, 6 19 right, 3, runway 28 right, clear to land.
Clear to land, 01 Sierra Charlie.
And it's not disjoint. And that's the kind of magical stuff that you can start to create with tech like this. And, yeah, you can imagine you have your NPCs, maybe you keep trying to sell them, cabbages, and it's like, stop telling me your goddamn cabbages. Like, it just gets progressively angrier. Like that would take so much effort to pull off today. Whereas, when you start to have these voices that you could synthesize dynamically, you've got a whole realm of richness and possibility for that experience, which was just not there before. So I think there's a lot of really, really fun stuff going to happen.
I can imagine all kinds of use cases, like sports games with the commentators, and just being able to have NPCs with a much more rich and textured experience. I remember when Star Wars: The Old Republic MMORPG came out, they talked about how they spent tens of millions, 100 million, some insane amount to just do recording for every single character in the game. And now maybe that capability will be in the hands of anybody who creates a game. You'll be able to do that. So we always forget, or not me, but a lot of people forget, yes, as the nature of work changes, one thing may kind of shift out of the picture, like maybe traditional performance is the only way to do things, but then the exponential growth of many, many more types of jobs, more use cases, more game studios in this example, able to add voice in many more circumstances, and often a lot of that improvement in the overall ecosystem will come back to this new type of voice designer, voice creators who can help trailblaze into this. So
totally, and maybe also the monetization strategies will change a little bit, right? When you look at the industry today, you're paying for performance, right? Now, I think they're going to it's a little bit ambiguous to see when this will happen, but I think we're going to move more towards like a world where you're paid when people are hearing your voice, right? It maybe, right? That could be a possibility. And in that world, you have a huge, potentially a big benefit as a voice actor, because if a game gets really popular, now you're being paid more on like a royalty basis for how often it's actually your voice is being spoken out. Maybe right now there's a lot in there that could happen. Monetization structures are very hard to change, but possible if there's enough benefit, they will actually change, right? And this mirrors a little bit closer what actually happens on the TV side of the world, right? Where you get paid when your stuff is shown, and when it's being shown overseas, you're getting paid for that as well. They've tied a little bit more to the performances of it rather than the you actually get paid up front. But then there's also the continuing, being able to continue to make money off of it after long after the performance, and maybe we're going to move to a world more like that, right? Maybe we'll see. But I really want to make sure that the voice actors and everybody is able to come along into the new world and not be not I don't want the job to go away. I think it just changes a little bit.
And maybe by the same token, also continuing evolution in the business models for the game studios themselves, where they are incentivized to keep creating content. So instead of thinking of like the cost going up all the time as people listen to more and more voice, maybe in fact that's something people want to pay for. They want to be subscribed to your game. They want to make in-app purchases or whatever it is
Yeah.
that continues to add to the game. So the future is going to be a little bit weird. It's going to be different. There's a lot of cool things happening here, but I think you said it with the word magic. Like we're entering this era now, whether it's the generative AI of GPT-4, diffusion models, what you're doing, voice, where there's so many magical things. So we're going to be in magical experiences from here. And I want
and the magic, right? It can also be in the form of just more content, right? Like you look at how much effort goes into like a DLC that your player base will just blow through in a weekend, right? And you're like, wow, that is like really not like you need to do that to keep your player base engaged. And you look at some of these other games that have done like we're shifting, games are changing more towards this, like you've got seasons, you've got like keeping the player base, like there's ever changing, ever evolving world. And yeah, if we are able to just imagine how much more engaging of an experience you're going to have when you have the ability to pump out more of this, and it's going to be compelling, and like it's not going to just be, oh, I'm playing the same maps but they're slightly different. Like I remember I was like, I was an early Destiny player, right? Slight anecdote. And this because my roommate and I at the time, we it was one of our ways for us to connect after work. He worked at Apple, I worked at Google, and we're just like, you know what, let's have something where we can just like shoot monsters together, right? So we were engaged, and we sort of ran out of the content, and it turned into this sort of grind, right, of just like more levels, everything. And I remember there was like a DLC. I think it was like maybe like the third. It was like the later part of the year. Like you buy the year DLC, and then like the last one or the second to last one, we were just playing the same maps backwards. I was like, wow, like I get it that content creation is hard, and I totally understand why they did it, but I was also like, I felt a little bit like I got ripped off, right? Because I was like, I wanted something new, right? And like we did enjoy the DLC, we totally did, but at the same time, imagine those voice characters too. Like you heard a lot of the same lines over and over again, like we've awoken the hive, like the same thing over, and just like imagine if that changed. That just bring a little bit more joy and spark to like that environment. And I think games are gonna be so amazing.
Yeah, more content that's high quality, but also putting it in reach of everybody. So everybody in the
Yes.
future will be able to
Yes.
create a live services game where you have this incredibly rich content, and it might almost seem like you're a AAA game company, but on an indie budget, you'll be able to make this stuff. So
or UGC, right? Like you kind of where you're going with that too, right? Like UGC, like imagine, like today, a lot of the world building tools that you give to your community, you get a lot of the same like models that you can put in. You have some of the same triggers. You can treat some of the same mechanics, but there's no way to do voice today. There's like no way, because I mean, you can have sort of, you can go pull robotic voices off the shelf. You can or you could record some lines yourself, but it's not going to feel like a part of the original game. And it's pretty powerful.
Yeah.
Like to be able to give the same tools to your user base to say, go wild, create some fun things in this environment. Now, of course, with all the safeguards and stuff that UGC people have to do anyway, right? But with those in place, being able to create experiences which feel part of the main game, if that's what you do, if it's built off of a main game, as opposed to like a Roblox kind of thing where it's just everything is a whole bunch of different, like there's no really one main game. But like imagine for example being able to do like GTA, right? Like add on like UGC for GTA, where you got your fun maps, but then at the same time it brings in some of the voices from the main story. It's way more compelling, but we have not been there before, and I think we're going to be there very shortly, and that's what's exciting to us.
Interesting, and in parallels, the way I hear about people who are working towards art systems like 2D, 3D graphics within games to establish style consistency. it's a problem within studios because they want to be able to scale out content but maintain consistency. But again, on the UGC side, how do you allow a player community to sort of build off of that without it looking like super disruptive in the negative way of disruptive, and like things that just don't match? So like super interesting. I hadn't even occurred to me. So generative AI is going to apply to so many things that allow us to scale up content creation and make these magical worlds and experiences. Zach, this has been an amazing conversation. Thank you so much. I hope that you are incredibly successful with Element, and want to thank you for being on Building the Metaverse. And we'll put those links down in the show notes so that people can check out all these things. You should definitely immediately go from this to listen to some of those demos that Zach and I were talking about. Thank you, Zach.
Thanks for having me on, John. This is really, really fun.
My pleasure.